Welcome back, students. Let me move to the next problem now. The problem number is 5.9. Let me read out the problem for you. The problem number is 5.9 with reference number 3 from the VTU question bank, and this is a problem that belongs to drawing number 19. The problem is like this. Draw the isometric projection of a rectangular prism. The dimensions of the rectangular prism are 60 by 80 by 20 mm thick. So the base is 60 by 80 and the height is 20 mm. Thickness in the sense it is the height of the prism. Okay. So the base is a rectangle 60 by 80 and the height is 20 mm. Surmounting a tetrahedron. Surmounting means it is carrying on that. Okay. And this rectangular prism is carrying a tetrahedron of sides 45 mm, okay, such that the axes of the solids are collinear and at least one of the edges of both the solids are parallel to VP. So it's a combination of a rectangular prism and a tetrahedron. You know what is a tetrahedron? Tetrahedron will have 4 surfaces and all the 4 surfaces are equilateral triangles, 3 lateral surfaces and a base. So you are going to place a rectangular prism first. Over that you will keep a tetrahedron so that at least one side of the tetrahedron is parallel to one edge of the rectangle. This is what is the requirement. Now when you have a tetrahedron, you don't know what actually is its height. Only the base edge is given for the tetrahedron. The base side is 45. So what I will do is, first I will draw the orthographic projection of the tetrahedron to find out what is the height of the tetrahedron. So you should do that first. Then only we will move to the isometric projection. So let me start drawing the orthographic projection of the tetrahedron. Let us say this is XY line, VP and HP. Tetrahedron, the base will be a equilateral triangle, you know that. So I'll start by drawing one base edge perpendicular to XY. This should be 45 in length. Then you draw an equilateral triangle. The base will be an equilateral triangle. That means you have to use 60-degree angles. So each of these edges are 45. Now let us name the corners A, B, C. You also have to find the center by drawing perpendicular bisectors. So this is the center. You can call it O01. Okay. Now let us draw its front view. This is the axis line. Now because OA is parallel to XY, O dash A dash will be true length. The true length is 45 here. So take A dash as center, 45 as radius. Cut this. So this dimension is 45. So this is the true length principle, one of the true length principles in your projection of straight lines. This is O dash. Now this is B dash, C dash. Now all this I have done to find out what is this height of the tetrahedron. This will approximately come to 37. Approximately it is 37. Manually when you are using, you can use 37. When you are using solid edge, you can use it with the fraction, 36 point something I think. Okay. So this is the orthographic projection of a tetrahedron. You have already done it in projection of solids. So this is required to be done before you attempt drawing the isometric projection, because you want to know what is the height. So I got the height now. Now I can start drawing the isometric projection. Let me start by drawing the rectangular prism first. The base is 60 by 80. So I am drawing two isometric axes, both inclined at 30 degrees. We assume that the base is on HP. So along this axis I am taking ISO 80. Along the other axis I will take ISO 60. Okay. Now complete the isometric projection by drawing two isometric lines. So this is ISO 80, this is ISO 60. You can take the other way also. This you can take ISO 60 and along this you can take ISO 80 as well. After getting this box, now you will take the height. The height is given as 20 mm. So at each corner you will erect perpendicular equals to ISO 20. This is not actual 20, this is ISO 20. Now connect all the tips of the perpendiculars. Now erase the lines that are not required for you so that the top surface is clear. So on this top surface you have to keep the tetrahedron centrally. So let us find the center now by drawing isometric lines. This is ISO 80, so you can mark ISO 40 and mark the center. This is ISO 60, you can mark ISO 30 and mark the center. Now I will draw two isometric lines to find the center. That's the center. Yes. Now let us keep this triangle in a box here. Let us call this as O, A and B. OA and OB normally we take. Now from the center you draw two perpendiculars onto the box. Okay, these center lines are important. Okay. Now this center corresponds to this center here. Okay. Now look at these two center lines. Your concentration should be on these two center lines. This center line is parallel to OA. So if you take this as O dash, A dash and this as B dash. Okay. So this center line you have to draw parallel to the edge OA. That means along this. So from the center you take this distance which is there to the right, find its isometric length and then mark it here on the right side. Now there is a small distance to the left. Okay, that its isometric length should be marked here. Have you understood? I'll repeat once again. You have included this triangle in a box, then you have already, the center is already there. Passing through the center you have drawn two perpendiculars. Okay, this line is parallel to OA, this line is parallel to OB. Okay, now both are center lines passing through the center. Now my concentration is on this line which is parallel to OA. So that means I have to mark it on this line. So from the center I mark this distance, the isometric length of this distance towards right, isometric length of this distance towards left. Got it. Now go to the other center line, this center line. For this center line these two distances are equal from the center. Okay. So mark isometric length of this or this from the center on the other isometric line. They are equal. Yes, done. Okay. Now you get the box now. Whatever box you have here, you draw its isometric projection now. By drawing isometric lines. Yes, there's the box. Now you can get the base of the pyramid. This is the base. That's the base of the tetrahedron. Once you get the base, you know the height. The height is 37. So from the center, you are going to take ISO 37 along the vertical. Let us say this is ISO 37. This is the apex. Connect the apex with the corners. You can use dark lines now. Now the remaining portion of the rectangular slab can be made dark. That's it. So this is a tetrahedron placed over a rectangular slab. What is important in this problem is to find the height. Unless you have the height with you, you can't draw the isometric projection. And also finding the center here. Finding the center is also important. Drawing the box that corresponds to the base. That's also important. Only thing, after getting the center, you also have the center here. This center will coincide with this. So your concentration should be on these two center lines. So with the help of these two center lines, you are able to get the box. That's what I did. First I have drawn the center lines there. Then using those center lines, I could get the box. Once I got the box, I could connect and get the base. That's what I did. Okay. So this is problem number 5.9, combination of two solids, a tetrahedron and a rectangular prism. I'll take a short break and come back, students, and I will solve the last problem for today, problem number 5.10.